Good morning, everyone. I hope you're enjoying the first ever Virtual Industrial Control System Joint Working Group and are getting something out of our efforts. My name is David Connor. I'm a security analyst for the Idaho National Lab. I've been working in modeling and simulation on and off for the last decade, first starting with the SuperSim project, which was geospatial based. For the last couple of years, my main task has been building the Control Environment Laboratory Resource, or CELR, for DHS. Thanks for participating in my presentation titled Improving Industrial Control System Security with Model-Based Control Design and System Virtualization. Or as I like to say, the CELR and how I came to love the CLI. Feel free to post a question in the chat tool at any time. We'll stop with the presentation now and then so as to answer some questions. At the risk of sounding like an apple polisher, no project can be successful without leadership and a champion. In our case, we have two of the best. Mark and Jean are far from the stereotypical feds. They are hard-driving, progressive, and highly knowledgeable. Folks at the INL have been talking for at least a decade that an industrial control system testbed needed to be built. That is no longer the case with the creation of the CELR. I'd also like to thank my daughter for putting up with all the work that I've been doing the last couple of months. Work in homeschooling is no mean feat. This presentation is meant to be informational, so we are not going too far into the weeds technically. Besides the fact that PowerPoint best practices suggest staying away from getting highly technical. And most of all, we don't want this to be another death by PowerPoint exercise. So if this presentation comes off as a little generic, it was meant to be, so that all the folks listed in this slide could benefit. Note that as a public entity, we don't get to call out our favorite tools. This is a neutral presentation in regards to vendors and such, both commercial and open source. Just to make sure no one has fallen off the bandwagon, I'd like to extend Fred Brooks' commentary on software development to security. There is no one tool, technology, or person that's going to secure your systems. Only through layered defenses can security be maximized. But what does layered defenses mean? If your network is crunchy on the outside and soft on the inside, you have not implemented layered defenses. In other words, if all you've implemented is a firewall at your network border, but don't have any network monitoring, no visibility into individual workstation activity, no SIEM, and no antivirus, then you need to revisit your security program. I'd give attribution to the crunchy network analogy, but even with some amount of Google foo, I was unable to determine the author. Feel free to fire up that chat tool if somebody knows who authored that analogy, first authored it. Of course, we couldn't survive without our minimum daily requirement of acronyms, so here's a few that will pop up during the course of the presentation. Most of these you're familiar with, but just in case, we'll list them here so we're all on the same page. Take a moment to digest all this. Just to be consistent, I'm making an executive decision in regards to the hierarchy of these topics. Model-based system engineering is the parent topic, while model-based control design is a subset of that. Here is our goal. We are going to improve security with math. Now, take a moment to digest this slide. Now don't run off just yet, it sounds much worse than it actually is. Besides, what could be more pure than a technology based on ones and zeros? So if binary is such a pure numerical system, why is there so many security problems with technology? You might argue that you don't have the budget to pursue these solutions, but there are cost-effective options when implementing modeling and simulation. Not everything needs to be gold-plated. I bet the IT department might have some old equipment that they're willing to part with. If not today, then maybe tomorrow. With a little bit of creativity and ingenuity, a modeling and a simulation program can be pursued without a big budget. We'll get into the details of how to accomplish that a little later. I would argue that math is the foundation of either of these tools. So we're going to improve security with math. The first part of this presentation is more thesis than applied science. Anyone willing to fund a research project or a case study? I didn't find many real-life examples of model-based design security analysis. So here's a question for the audience. Has anyone used model-based design? And is there a reason that you didn't use it for security analysis? For some reason, as popular as model-based systems engineering is, applying that tool to security hasn't become as popular. But given the growing threat that we're all faced with in regards to our IT systems, let alone our OT systems, it seems like we should be leveraging all the tools we have available. Now, the second part of this presentation is a review of the Industrial Control System Modeling Project at the Control Environment Laboratory Resource. Benefits. If you're in the initial design phase, you can find errors before making a full investment in the finished product. Changes can easily be made in the design phase. You can pursue all sorts of what-if scenarios without dramatically impacting the cost of the finished product. And existing design can easily be remodeled, extended, or recycled. And of course, there's nothing to keep you from doing an analysis of an existing system. Have I missed anything, or is there any confusion regarding the benefits of system modeling? Feel free to chime in on the chat tool. Model-based design, where security is concerned, continues to be more academic than applied. Like I've mentioned, there's lots of academic papers on this topic, but not a lot of case studies or documentation of real-life implementations. Commercial tools can be expensive. Oops, I feel a soapbox coming on. And at the risk of getting completely off topic, security is expensive, but I would counter that point by saying poor security is even more expensive. Here's a little cost center analogy. The ski patrol department at your favorite ski resort is purely a cost center. But even if management wanted to go without a ski patrol program, there's no risk manager or insurance company that would approve of such a move. A security program is purely a cost center. But what company can afford to go without a security department? The FBI on ICS3.gov reports a 30% jump in the cost of reported cybercrime from 2018 to 2019 for a total, I believe, of $3.5 billion, which begs the question, how much cybercrime goes unreported? So we've gone from the notion that we can secure our IT systems to it's not a matter of if, but when we'll have a security incident, and we better be prepared for it. I would argue that the same mentality should be applied to our OT systems, which leads us to the next bullet item. Cybersecurity in an OT setting continues to be bolt-on rather than integrated from the start. Of course, that has something to do with the nature of our OT systems, the lifespan of which are measured in decades. But a defense in depth mentality includes security planning and analysis. Any arguments against this list or glaring omissions? Please chime in on the chat tool. Is there anyone who hasn't at least heard of the Unified Modeling Language? If you've ever participated in a code review of even something as easy to read as C#, you know that having a common standardized vernacular is required if folks are going to communicate effectively. So way back in 1994, some really smart folks at Rational Software, Booch, Jacobson, and Rumbaugh, came up with this standardized methodology for explaining a software system. But wait, there's more. Unified Modeling Language is advertised as a general purpose tool, so we can use it for something like OT security, maybe? And in fact, UML has been extended for use in a great many design problems. For example, here are some languages that can be used for modeling security. UML-sec is more for dynamic analysis. Secure UML is helpful when performing static analysis. Systems Modeling Language, or SysML, is more appropriate for control system modeling, which is exactly our topic. Imagine that. Just to get an idea as to how detailed and thorough a model-based analysis can be, here's a list of the types of diagrams that you would create for such an effort. Take a moment and peruse that if you're not familiar with it. All the taste and 1/3 the less calories. SysML Lite. If you're just getting started with this type of analysis, why not start with a smaller set of diagrams? At the risk of heresy, I've included Visio in this slide, if only because there are a number of templates available for Visio. This tool provides an easier path towards getting started with a model-based security program analysis. And in fact, UML is built into the system. So we have some commercial tools here. LabVIEW, MATLAB, and Stateflow and Symlink, Target Lake, and then of course Microsoft Visio. Admittedly, open source tools can be free like kittens at times, but in general, the benefits outweigh the costs associated with those undocumented features. Here are some projects that have employed model-based design tools to analyze security. Kang et al. Model-based security analysis of a water treatment system. Admittedly, that was just a test bed, but it is a real-life example. There's also Jensen et al. Availability of a SCADA OMS DMS system, a case study in which they used MBD for a power utility and analyzed security there. Due to time and real estate constraints, we are going to have to switch gears now. In conclusion, model-based control design might be more appropriate for large complex systems. A very small co-op utility might not find benefit from this sort of analysis. Even if a system is already built, if you haven't performed a security analysis, you could benefit from this sort of review. And if you already have a model-based design, there's low-hanging fruit in adding a security aspect to that documentation. Let's take a look at some questions and then move on to system virtualization. System virtualization. You don't have to mortgage the farm to create a virtualized model of your own systems. As I've mentioned, there are options when acquiring hardware, software, and licensing that are cost effective. How do you get from planning to a finished product? As I previously mentioned, the seller has been a success due to having a couple strong project champions. But we also had a very broad use case in mind, including analysis, training, security, and planning. Where your project is concerned, I would add that having a solid inventory of the systems you want to model, as well as having staff available for the project, would go a long way towards project success. From planning to finished project. Here's our building management model, complete with BACnet chatter on the IT network. Building management and IT on the same network is not something that I would suggest, but sadly, something that does happen in real life. Just a quick insight into our experiences regarding staffing. For whatever reason, the field and service employees we've tried to recruit, even though they were extremely qualified, have not taken an interest in modeling and simulation whenever we've given them a chance to help out. On the other hand, we've had some resounding successes with interns. I liken hiring interns to a baseball farm system. It's a great way to evaluate talent, groom potential employees, and get those really talented kids plugged into your company. Don't sell these institutions short. They can be a great source of talent, and I would argue that techs are just as important as senior engineers when putting a virtual model like the seller together. You want your senior engineers working on a red team, blue team sorts of design and implementation things, not just plugging in network cabling. And we've been lucky enough that we have all four of these within the region. Tech schools are a great source of interns as well, not just college students or grad students. Any modeling and simulation budget should include, at a minimum, hardware, software licensing, and location. Let's take a deeper dive into these and see what we're talking about. Don't forget the used option. For those of us that are cost conscious, there are alternatives when building a virtualization system. You can even buy used control system components. You might even be able to duplicate some of that really old systems that should have been retired years ago. There are multiple options for licensing too. There are ways to license affordably. Open source being the most obvious one, but there's development licenses and trial licenses to leverage as well, if you don't mind a little churn with your systems. A closet is not a good place for a server room. HVAC needs increase dramatically the more servers and equipment you add to a system. And if you're already space restricted, you aren't going to be able to effectively cool hardware. Please note that 208 is far more desirable than 110 where servers are concerned. Now, virtualization can work over gigabit networking, but 10 gig is even better. Oh hey, does a gigabit? Not if you pet it nicely. All forms of humor are required when little ones are stuck at home for a couple months. Budget, goal, plan, staff, and location, all in place. Now the fun begins. Say, how about a virtual show of hands? Do you recall your first technical or engineering job? And how about the very sage advice you got from one of the more chronologically enhanced members of the team? I certainly do, because here I am making a difference with just keeping the corporate plumbing up and running, just like it was suggested to me so many years ago. The modeling pyramid, IT/OT modeling period. Time is the basis for any virtualized model, if for no other reason than computers in Active Directory need to be synced where time is concerned. Otherwise, you get trust issues, and there is no amount of counseling that's going to help AD and Windows 10 work things out. And if you're going to have incident response training, it helps analysis when time is consistent across the board. So time is the foundation. The hypervisor you choose is next. Not only do I not get to state our preferences here, but there are several options. So one over the other is really personal preference and budgetary driven. And then, of course, scripting determines the hypervisor that you choose. In order of preference, here are some options for keeping a system on time. GPS-based and TP servers are not all that expensive, but you do need line of sight to the sky for an antenna to get a strong enough signal and actually work. A combination of virtualization host and a virtualized NTP server works almost as well. And if you're really brave and not going to run any malware experiments, you could always just open your system up to the World Wide Web and hit a traditional NTP server to sync with. Hypervisor. Here are common options for the hypervisor host. As I mentioned, your affinity for open source software or your budget goes a long way towards influencing your decision here. I've worked with most of these, and they all have their advantages in one way or another. Of course, the hypervisor platform predicates the scripting language. Scripting is the key to efficient manipulation of systems in regards to build, manage, and orchestrate. Warning, I'm getting back up on the soapbox. Here's my op-ed regarding scripting. There's no easy button where scripting is concerned. Scripting is a very powerful tool, but just because you can read it, don't have to compile it or require a special tool to build it, doesn't mean that good scripts are easy to build and just fall out of the sky like manna from heaven. A good script takes almost as much time and effort to build and might be as complicated as a compiled language when finished. And hopefully you recognize that thought bubble in the corner there and what I'm implying. There are folks out there that have taken building virtual systems to a whole nother level by automating the entire process. Hydration Kit by the good folks at deploymentresearch.com is one such option. This tool has been tested on both Hyper-V and VMware, but it is suggested that it would work on any virtualization platform that allows for booting from ISO. There's also a couple of image factory projects for Hyper-V and Microsoft Development Toolkit by different authors. There's also a project called Automated Lab that enables creation of full systems on Hyper-V or Azure. I would suggest that your mileage may vary, and I've already expressed my opinion regarding silver bullets and scripting. And here's my rant regarding automated builds. It has been my experience that while automated builds work, having pre-built templates to clone from is faster and more reliable. I don't have any official benchmarks to support that notion. It's just my preference based on anecdotal evidence. And who am I? Just the worker bee. Given that Microsoft is so integral in any IT/OT environment, some type of Microsoft licensing is required to enable modeling of a system with any fidelity. Trial licensing usually only lasts 30 days. Visual Studio subscriptions, formerly MSDN, gets you a suite of Microsoft licensing and obviously Visual Studio, but it doesn't get you Office. And if you look hard enough, there's just plain Microsoft OS licensing available as well, particularly if you're in education or a single entity. Those sorts of licensing come in really helpful. Building the seller has been an exercise in troubleshooting. Is it just me? Because no matter the vendor, there's always something that doesn't work exactly like it should. And as always, there's never enough time to document as much as you need. So fire up that wiki first thing before you even put together the first system. In fact, the first system that you should build is a wiki. So I've always wanted a top 10 list to compete with the other famous Dave, but we just have room for 5. So here's my top 5 list. Microsoft says you have to sysprep, but actually you don't. And the clones will last longer and be more robust if you don't. You can use a template to clone with, and you can clone the clone and do that quite a bit more than if you started off with a sysprep system. After about 5 or 6 times under that scenario, your VM loses its mind and you may as well just throw it away and start all over again. So don't sysprep to start with. Take my word on that one. So I've got a full slide for the next point, and we'll get to that in a sec. VMs with Wake on LAN turned on is super helpful when you're trying to orchestrate things like GPOs or pushing out new scripts for traffic generation and the like, scripts for trying to keep things time synced and also connected to AD. If your modeling and simulation system gets big enough, you will need to manage it just like you would a production IT system, which means investing in tools like Nagios, iDRAC, and Ansible. And like I mentioned in the last slide, wiki. Get that wiki going. Being super cheap on power, networking, and disk space will eventually come back to bite you, and the you know what. Too cheap it is just as bad as blowing the budget. So you have to invest in at least a minimum level to have a platform that's going to be functional and do something for you. Here are some of the things that should be included with a workstation template, and especially if you're wanting to do incident response training. I mentioned scripts. Since most systems are 90% Microsoft prevalent, it's going to be PowerShell scripts. But PowerShell, like I mentioned, scripting is really powerful. It can be used for traffic generation, management. There's all sorts of sysadmin things that you can do with PowerShell. Both with the servers and the clients. You want Office. Office is a great thing for the red team. They like their vectors of attack. And we go so far as to installing things and then not patching it so that the red team has a little more something to work with. And then companies have a typical suite of tools that they have on their workstations, Adobe, maybe Java still, Teams, Skype, those sorts of tools are commonplace in an IT environment. Pro-grade traffic gen tools, but also pro-grade prices if Your budget does not allow for these. Let's take a quick look at the next slide. Open source traffic jam, once again, free like kittens. TCP replay, traffic jam with PowerShell to a degree, packet sender, and interestingly, Cisco not only has a commercial tool Viral, but they also have an open source tool called T-Rex. There is a cost benefit associated with either model-based control, design, or virtualized modeling. How that applies to your company will vary case by case, but at least in our experience, a great deal of benefit can come from the effort. Our most aesthetically pleasing model, another great example of a success. This kind of product is what you get when you have incredibly talented crafts and OT engineers. Yes, it's pretty, but it's also highly functional and realistic. So let's take a look at an example of how such a model might be used. This is not a condemnation of any particular vendor or product. Did I mention that this was not a condemnation of any particular vendor or product? Oh, and by the way, this is not a condemnation of any particular vendor or product. This is a training and display example, a defense in depth fail. So, have the cyber criminals been practicing social distancing? Have they taken a break from their malfeasance? And I use that word specifically because the definition is wrongdoing, especially by a public official. Hint, hint, nudge, nudge. So during the last couple of months, there's been a huge issue with fake SharePoint sites, toyota.industries.my.sharepoint.com. There was a ransomware attack on a state-owned Taiwanese energy company. There's been ransomware activity on the European medical and pharmaceutical manufacturing. And the Snake ransomware has hit some major European healthcare companies. And the Israeli government says that hackers have targeted its water supply and treatment facilities recently. So I would argue that during the last couple of months, there has been no decline in security issues. So here's a red team dream recipe. The red team, of course, being the folks that try to hack into the system to test its security measures. In this make-believe case, we see that there's little or no security, and this is what could possibly happen if you failed on multiple levels of security. Attribution in this case is easy, because we know that Jeff Klingler, now the INO lead for the Cyber Sentry project, built this attack scenario. So once again, security failure on all levels, just for training and presentation purposes like this. Okay, so admittedly, there's a great deal of don't mind the guy behind the curtain, Wizard of Oz scenario going on here, but let's do our best with the platform that we got. So, oops, someone clicked on a link that they shouldn't have, which was compounded by the fact that the Eternal Blue patching didn't get taken care of in time. Now, someone has a foothold in your system and has managed to hack an account that gives them administrative privileges. Recall how powerful scripting is. Technology and tools are not just for the white hats. The black hats have access to the same tools and hardware that we do, but they don't have the regulations and government bodies that we have to answer to. Here we see a Metasploit exploit being set up. Metasploit being one of those tools that give the red team, as well as black hats, a great leg up on nefarious activity. So not only has someone hacked into your IT system, but sans network segmentation, they're messing with the OT side as well. So what we didn't fully see in the previous slide was that not only was a connection made to the HMI at 192.168.60.2, you should have seen that in the command line, but an executable was dropped as well that enables one to trip breakers. The bad guy has just tripped the breakers, but given the polling rate of the HMI, even if someone was monitoring the system, they wouldn't have seen anything. Admittedly, this is a very contrived scenario and not necessarily 100% based on reality, but nevertheless, a really good beginner to intermediate training scenario and great for presentations. Now, once again, this is not a condemnation of any particular vendor or product. This is a complete defense in-depth fail for training and presentation purposes. Now, just in case I failed to get the points across, model-based control and system virtualization can benefit security efforts. Good luck everyone with your security endeavors. Thanks for watching. If you don't have any questions, please stay safe and healthy. Otherwise, I'll head on over to the chat tool straight away and answer any questions.